At the TU Delft, we are interested in how to meaningfully design technology to improve people's daily life and working life. In the professional painting industry that SUSAG represents, there are some issues. And then technology is a possible means to improve that work, to make it less heavy. We have set up this project together with Nasli Sila and myself. My role has been to coordinate the meetings, to bridge with design education, to look at opportunities for helping the field, but also to look for interesting directions.
SUSAG is an organization. It's a deal between workers and the entrepreneurs. We are financing health projects, and one of the goals is develop new technologies for the painters to make their work lighter and healthier.
Onderhoud NL is partner of SUSAG, and the project focuses on sustainable employability, reducing physical strain of employees in our industry, the painters. I focused on explaining the health and safety issues during a kick-off meeting with the students and feedback during their presentations.
We as Muses had the role of design researcher. We investigated the needs, preferences, experiences of painters. We mapped what their future needs would be.
My role in the project was mainly the research that we did in the beginning as a part of the context mapping method. We interviewed a lot and also made an analysis to prepare them for the questions that we would ask.
We let them make their own answers, so they get very physical materials to really map how they experience their daily work. These experiences formed the basis for a design vision that was later used by the students in developing their concepts.
I joined this project just sort of at the tail end of phase one. I'm from a more engineering background, and so my main interest is how do we actually make these things real. The progress up till now has in large part been through an assignment for students doing the advanced concept design course.
My name is Job Nijen. I'm currently a 5th year student at the TU Delft.
My name is Fabian Hoogendijk. I'm a 5th year student here at the TU Delft.
My name is Adam Rehber. This is my first year in TU Delft.
The project started with group research where we dived into the culture and the economics part in the painter's job.
It hasn't evolved a lot since the 12th century, and we saw a lot of opportunities there as well.
We observed and we did interviews with painters, really get inside their head.
The focus of my project was the well-being and the health of the painters. Because their job is quite repetitive, their musculoskeletal well-being is diminished, mostly focusing on the standing operations, one of the biggest pain points of painters. The principle is reducing the weight on upper arm and hand, moving the heavy components to the lower body, ensuring them to have very light load while they're operating.
I focused on making the work for painters healthier. The sanding phase is the most annoying part because it's dirty, heavy work, and they don't like to wear face masks because it gives them an unpleasant feeling. So I designed the products they can wear and hopefully will increase their health.
I had like the one specific moment where I saw the painter carrying everything every 2-3 meters. I thought, hey, this can be done differently. Improve the quality of work of the painters so they can enjoy it more in a way.
Painters do love their crafts, so I just wanted to preserve the parts that they love and provide them a specialized experience. I established a method called RULA, the Rapid Upper Arm Assessment, where we are measuring the angles and the postures to ensure the well-being of the painters.
My product design is about keeping the finest particles away from the painter's face by blowing the particles away through a fan that it's working on the back of the head, then gets blown in front of their face. It sort of creates an air shield, and that way the finest particles cannot enter the painter's nose, mouth or eyes.
My solution is a robot cart that follows the painter around, that carries its stuff, creates something that don't replace them, gives them more support, then takes their job away, help them improve their work.
Technology could bring added value in different ways. You could see it as a sort of superpower.
They can augment you, they can make you stronger, smarter, they can make you see things that you cannot see with your human eyes. Smart agents, they're robots, but they're also tools, more of a partner than something to delegate to.
SUSAG, when they gave us the presentation, mentioned that robots are not things that they're very keen of. But then when we talked with them, there was a different opinion.
We heard a lot about the painters not wanting to be replaced by robots. So it's very interesting to see how the students create really helpful solutions for the painters to change their daily lives without changing it too much that they wouldn't accept
the repetitive motion that painters do is deriving their culture. If a technology, no matter what it is, alters those repetitive motions, those are not appreciated by the painters.
Another challenge is that these smart agents should not make a person feel weird. We have examples of exoskeletons. Although they technically do things well, they're just too weird to wear. We need to really consider how they are shaped, how they are formed, how they make you look good.
Now it's up to the TU Delft and SUSAG to see okay, how can we make these concepts that are now developed based on our research into a more experiential prototypes and also let people react on it.
We have discussed 6 points they all should do. If they leave out some of them, it will fail to be actually implemented.
Productivity, less sick leave, and happy employees.
For my project, since it's a more conceptual product design, I think it's a very interesting idea and it can be made. But I think there should be a bit more research on the engineering part and getting the different experts together to make it actually a tangible product.
The most important step is to build it and to test it under the right circumstances to keep iterating it.
I find some technologies that are already existing in the field with right materials, with right production methods. We can basically have the prototype now. So my encouragement would go to producing the forms and testing it on the fields, because there is literally no technology that is awaiting for us to have this product.
This film is the end of part 1. There is going to be a part 2. A step further into an actual prototype development process. The user experience, the impact, the actual technology, the embodiment and the interactions.
Going from the purely design phase into a more engineering phase. Ultimately, we will need to take these hopefully impressive prototypes and find someone in the commercial space to, take them just that last mile, turn them into something that you can go out and buy.
And I'm very, very excited to see what comes out of it and what the painters think, if we did it justice.